Today I'm going to cover the second part of 14.2, okay, which is example 8. Then I will let you all try 8, and then we will be done with 14.2 itself. So first and foremost, okay, this is a piece of paper in the form of an equilateral triangle. Then smaller equilateral triangles are cut off from the corners. So we have the big equilateral triangle here. Then we have the smaller equilateral triangles, okay, at the corners there. Now, show that the area of each triangle that's cut off is root 3 over 4x squared cm squared. So now, if you look, all right, here is x, this is also x. If they're equilateral, this is 60 degrees. So each triangle, if you want, okay, so the area of the triangle, if you remember from trigonometry itself, from the part 1, okay, is half AB sine theta. So it's half, okay, AB sine 60. So if you remember from trigonometry, sine 60 is 0, 30, 45, 60 is square root 3 over 2. So what I get is half x squared times square root 3 over 2. So simplifying, you get square root 3 over 4x squared. And I have actually shown that the area of each triangle that is cut off, okay, is root 3 over 4x squared. So this is shown. That's part 1 in a nutshell. Okay, now I will move on to part 2 itself. So for part 2, they say that given that the parameter of the remaining shape is 18 cm, show that the area of the remaining shape is given by square root 3 over 2, 18 plus 6x minus 6x squared, okay, which is what they want us to prove over here. Okay, so now what I can actually start to do here is this. So I work with the parameter first. So parameter of u, v, w, x, y, and z is equals to what is given to be 18 cm. Okay, if you look at this question here, if this is y and this is x and this is x, it stands that this is y minus 2x. Okay, so going by the same logic, this is also y minus 2x, and this is y minus 2x. This is x, this is x, this is x. So the parameter itself, okay, is equals to, there are 3x there, so it's 3x plus 3 times of y minus 2x. And this is equals to 18 cm. If I simplify this, I get 3y minus 3x is equals to 18. So if I simplify and divide by 3, y is equals to x plus 6. Okay, let's just leave y alone by itself first. Now we need to show that the area is that. So what is the area? First, the area of the large triangle, so which is PQR. So area of triangle PQR is equals to half AB, so it's half times y times sine of 60 degrees. Why 60 degrees? This triangle itself is also an equilateral triangle. As we have done earlier, sine 60 is square root 3 over 2. So area of triangle PQR is square root 3 over 4y squared. Now, okay, what we actually need to do here is to actually substitute away, okay, this is only area of triangle PQR, then area, okay, of 3 times of a triangle, let's say PUV. Okay, it can be PUV, or basically what I'm looking for is these 3 triangles, and these 3 triangles we have proven earlier to be root 3 over 4x squared. So equals to 3 times of root 3 over 4x squared. So I get this 3 root 3 over 4x squared. Okay, I'm actually in a good position to actually find the area of u, v, w, x, y, z. So now area of u, v, w, x, y, and z is equals to area of the large triangle, root 3 over 4 y squared, minus 3 times of the small triangles is 3 root 3 over 4 x squared. Now, don't forget, okay, that we actually proved very much earlier that y is equals to x plus 6 from using the parameter itself. So what I can say is square root 3 over 4 x plus 6 square minus 3 root 3 over 4 x square. Let's make our life easier by factorizing root 3 over 4. So what I'm left with is x square plus 12x plus 36. I have expanded this portion here, minus away 3x square, like this. So, okay, let me just copy this out into the next page because I'm running out of space. If I carry on with the area of UVWXY, so if you simplify everything, okay, what you get is root 3 over 4. Then what we have inside is negative 2x square plus 12x plus 36. So this 4 here can be expressed as 2 times 2. So I will just leave it as square root 3 over 2 times half. So this half, I will actually multiply in here. So I'll skip that step. So if I multiply that half in, what I get is negative of x squared plus 6x plus 18, which is what they want us to show. I just rearrange into what the question actually asks. What we get is 18 plus 6x minus x squared. So this is that, right, for the area itself. So the area is this. I have actually shown that this is true. Now, find the maximum area value of A as x varies and justify your answer. So justifying means that you actually need to show that it really is a maximum area. So now, okay, I have this. A is equals to square root 3 over 2, 18 plus 6x minus x squared. So if I differentiate A with respect to x, root 3 over 2 remains, 18 differentiated is 0, 6x will give me 6 minus 2x. So for a stationary value, dA dx is equals to 0. Root 3 over 2, 6 minus 2x is equals to 0. Then the x value is equals to 3. Now, I need to still show that it really is a maximum value. From my first derivative, I obtain my second derivative, which is negative x. So if I sub x equals to 3, I will find that my second derivative will be lesser than 0. So this gives it, that it makes it a maximum point. So the statement I can make is, hence, when x equals to 3, A has a maximum value. And when A is a maximum value, and this maximum value of A is equals to, if you recall, there's this A that we actually proven earlier. So now they still want us to actually find what the value is. So if I substitute in the appropriate value of x, which is equals to 3, I get square root 3 over 2, 18 plus 6 times 3 is 18 minus 3 square. Simplifying, I get 27 root 3 over 2. And that's it for my example 8. Okay, I have done something. Now it's your turn to try. So please try it itself. Okay, and I will give you the solution in 3, 2, 1. Let's go. If you were racking your brains, okay, on how to actually prove that the area of the rectangle is in terms of x, okay, let me just give you some clue first. So this is y. So actually what we'll need to do is to actually relate y and x, because if you notice, the area doesn't contain any y. And also, secondly, in a context of an examination, if you cannot actually prove part 1, you can actually still let the differentiating a with respect to x be equals to 0. You can still solve part 2. So please don't give up the chance to actually be able to do part of this question. So if you're unable to prove part 1 and you're really stuck, okay, practice good time management, move on, and then try part 2 itself. Okay, that aside, okay, how we actually do this is the magical trick here is that this actually works with similar triangles. Okay, so now the similar triangle will work like this. Okay, this small blue one, okay, and this large red color one, like this. Okay, so earlier we have learned some values. So this is y. Okay, this portion here, okay, what we get is 12 minus x. Okay, so by similar triangles, what we have is small over big, small over big. So small is y over 5, then small 12 minus x over 12. Then what you can actually get is y equals to 60 minus 5x over 12. So in a way, what you have done here will be able to relate y to x. Then later on, when you can substitute away the y, so that you can actually get the a dx itself. Okay, so by similar triangles, from what I explained to you earlier, okay, what you get right is y is equals to this, from similar triangles, and this is the y value. Mine is slightly different. I wrote it as what I call 60 minus 5x over 12. You can also write it in this form itself. So now the area of the rectangle is x times y. So what we have done here is to substitute y with this value here, this expression. So I get a to be equals to this, and this is actually proves what we need from part 1 itself. Now for part 2 itself, what we can do is to differentiate a with respect to x. Then for it to be a maximum, okay, you allow dA dx equals to 0, solving your x value is equals to 6. Now, it's not sufficient to just get the x value. You still need to be absolutely sure and to prove that this is a maximum point. So by applying the second derivative test, I find that the second derivative is negative. So that means that when x equals to 6, a has a maximum value. And this is it for your exam try 8